All right, I'm going to do a couple of problems off of the practice problems for 5.1. So if you're having trouble, hopefully this will help you out a little bit. I don't know which ones are good. I'm going to do number 5. So number 5, they tell us the cosine of a negative s is radical 5 over 5. And they tell us the tangent of s is less than 0. And we want to find the sine of s. Now, they gave us the cosine s is radical 5 over 5. Now remember, for negative angles, the cosine is the weird one. The cosine of a negative s is the same as the cosine of a positive s. So the cosine of a positive s is also radical 5 over 5. So it's the one that doesn't change like you would expect. All right. Now, so we know the cosine, we're trying to find the sine. We want to look for an identity that has just cosine and sine in it. When we look at our identity sheet, this very first Pythagorean one, it has sine squared plus cosine squared equals 1. So it has the cosine that we know, the sine that we're trying to find, only those two, so that's why we picked that one. So we're going to start with that. We're going to treat it just like it was a formula. So sine squared s plus cosine squared s equals 1. Now we substitute in. We know the cosine of s is radical 5 over 5. So we're going to put that in here for cosine of s. So now we have that. Now we're going to solve. Well, if we square that, radical 5 squared is 5. On the bottom, 5 squared is 25. So now we have this. We want to get sine by itself, so we're going to subtract 5 25ths. Well, that's going to be 25 25ths minus 5 25ths is 20 25ths. Now we want to square root both sides because we have sine squared and we just want sine. So if we square root both sides, now we have the sine of s equals plus or minus. The square root of 20 is like the square root of 4 times the square root of 5. So that's 2 radical 5. And on bottom, the square root of 25 is 5. So we got that. Now we have to decide whether our answer is positive or negative. Well, that's what they told you this for. If the tangent is less than 0, tangent is negative in quadrants 2 and 4. They told us the cosine was positive. Well, cosine is positive in quadrants 1 and 4. So they have quadrant 4 in common, so we know we're in quadrant 4. Well, in quadrant 4, sine is negative, so we get rid of that. It'd be negative 2 radical 5 over 5. All right, let's also try number 15. Number 15 is a simplified problem. So it's 1 plus tangent squared over 1 plus cotangent squared. So we want to see if we can simplify that. Well, if we look in our identity sheet on the top, we have 1 plus tangent squared. Well, we have this identity here that says tangent squared plus 1 equals secant squared. So let's use that. So on the top, that's secant squared. On the bottom, we have 1 plus cotangent squared. Well, if we look at our identity sheet, right here it says 1 plus cotangent squared equals cosecant squared. So in place of this 1 plus cotangent squared, we can put cosecant squared. So now we have that. Now we want to try to simplify that. Sines and cosines are kind of the easiest to work with. We know secant is 1 over cosine, so secant squared would be 1 over cosine squared. We know cosecant squared. We know cosecant is 1 over sine, so cosecant squared is 1 over sine squared. Now remember, when we have a fraction like this, we take the top times the reciprocal of the bottom. So that equals 1 times sine squared on top, cosine squared times 1 on the bottom. So we have that. We want to simplify that further. Well, we have an identity that says sine over cosine equals tangent. If that's the case, then sine squared over cosine squared should equal tangent squared. If we did, let's say we also do 14. Let's add some common denominator work in it. So we have secant theta minus cosine theta. Well, secant and cosine are related, so the first thing I would do is try to get the same trig function. Well, secant is 1 over cosine. Now, if we're gonna subtract these, we need a common denominator. Well, our only denominator is cosine theta, so that's our common denominator, cosine theta. Well, this already has a denominator of cosine theta, so we leave that alone. This in our denominator is 1. We want it to be cosine theta, so we're going to multiply top and bottom by cosine theta. So cosine times cosine is cosine squared theta. So now we have that. Well, let's see, 1 minus cosine squared from our identity sheet. We kind of move this one around. If we move the cosine squared to the other side, if we move it over here, that'd be 1 minus cosine squared equals sine squared. So this top part, that's sine squared theta. You could leave it like that, or we could also think of that as we break that sign up. That's sine theta times sine theta over cosine theta. Well, this right here is tangent, so we could say it's tangent theta sine theta. That's just a couple of walk through there on 5.1.